All right, let's dive in. Today we're going deep on, well, deep stuff. Everettian quantum mechanics, or as some folks call it, the many worlds interpretation.
Yeah, it gets pretty meta pretty fast.
It does, which is why we've got the Stanford Encyclopedia of Philosophy entry on the topic to guide us.
A good one. It really gets into the philosophical weeds, which I appreciate.
Exactly. And that's our mission for today. Not just explaining Everett, but doing it as if we're, say, explaining it to a fellow philosopher.
Right, someone who might not be steeped in the physics, but is ready to wrestle with some big ideas.
So let's set the stage first. The measurement problem in quantum mechanics. What is it in like a nutshell?
Imagine a coin spinning in the air. You don't know if it's heads or tails yet, right? It's like a quantum particle. It's in this fuzzy state of possibility described by its wave function.
Okay, so far so good.
But then you catch the coin, force it to land, heads or tails. That's like taking a measurement in quantum mechanics. The particle chooses one state. How? Nobody knows. That's the problem.
So it's not that our instruments are crude, it's like the theory itself has this gap in explaining how we get from a wave function to a single outcome.
Exactly. And the standard equations, they don't explain a collapse of the wave function. They just describe this smooth evolution of possibilities.
Like the coin, in theory, never actually spinning.
Right. And that's where Hugh Everett III comes in. He's like, hold on, what if there is no collapse? What if all the possibilities just keep happening?
That's where things start getting trippy. So instead of a coin landing on one side, it lands on both, but in different, like, branches of reality.
Exactly. That's the heart of his relative state formulation. No collapse, just a multitude of realities, each playing out a different outcome.
Okay, my brain started to hurt. But here's the big question. If everything's happening somewhere, how come I only experience one outcome? Like, I don't feel myself splitting into copies every time I choose between coffee or tea.
Right. That's where Everett gets really clever. He talks about absolute versus relative states. Think of it like looking at a statue. You see it from one angle, I see it from another. Different viewpoints on the same statue, same reality, just different relative perspectives.
So I'm not splitting. It's more like my conscious experience is just one slice of this much bigger branching reality.
Precisely. He even used this thought experiment called Wigner's friend to illustrate it. Imagine a scientist, the friend, does a quantum experiment. They see one result.
But someone outside the lab, they could describe the whole system, friend included, as being in a superposition of all possibilities.
Exactly. Both are valid descriptions, just from different relative states, different viewpoints on the same overall reality.
This is wild. But then there's the issue of probability. If everything happens, doesn't that make chance meaningless?
Great question, and Everett's answer is subtle. It's not chance in the usual sense. He talks about a typicality measure across all these branches.
Meaning,
Imagine you could survey, like, countless observers across all those branches, each having seen a different outcome. Some outcomes would just be more common, more typical than others.
so instead of saying there's a 50% chance of this, we're saying 50% of observers across all branches would see this. It's about the distribution of experiences, not chance within a single reality.
That's it. It's a really different way of thinking about probability, and honestly, one of the hardest parts to grasp.
Definitely makes you wonder what it would be like to live in a universe where every quantum possibility, no matter how small, actually plays out.
It's a big thought.
A big thought, and that's just scratching the surface. But hey, we've got more deep diving to do, so let's take a quick break and come back to unpack even more of Everett's world, or rather, worlds. So, living in a universe of infinite possibilities. I mean, it sounds kind of cool, but doesn't it make our choices kind of meaningless if every path is being taken somewhere?
It's a question a lot of folks grapple with, for sure. But let's not forget, Everett wasn't just throwing out wild ideas. He was a serious physicist.
Trying to make a theory that actually works, mathematically, but also, like, connects to the world we experience.
Right, that's where the idea of empirical faithfulness comes in.
So it's not that a theory has to perfectly match everything we observe. It's more like it has to give us a useful map, even if it doesn't show every blade of grass.
A good analogy. A map doesn't need to be perfectly realistic to help you get where you're going.
So how did Everett argue that his theory, with all these, unobserved branches, is actually faithful to our experience?
He had a few main arguments. Firstly, he said, look, what we experience are those relative records of measurement outcomes. That's how we interact with the world. It's what our consciousness is built on.
So what we see, feel, think, it's all happening within a specific branch, not the whole crazy branching reality.
Precisely. And secondly, he said, we wouldn't even notice the branching most of the time because of how those records form within our branch.
It's like if you're on a train, you're focused on what's outside your window, not the fact that there are tons of other tracks and destinations happening at the same time.
Right. But then you might think, okay, but couldn't we find evidence of those other branches, at least theoretically?
Like proof that they're actually there. not just some mathematical quirk.
And that's his third argument. He said, yeah, it should be detectable in principle, this branching. It's not like it's just extra stuff with no consequences.
But it's probably happening at like such a subtle level in the quantum realm that it's incredibly difficult to spot in our big, clunky world.
Right. Which brings us to perhaps the most important point, and that's probability. If every outcome is happening somewhere, how does that make sense in our experience?
We're back to the coin toss. If every toss results in both heads and tails, why do we see roughly 50-50 in our lives?
This is where Everett uses his typicality measure idea. Basically, if you could survey observers across all branches, what you'd find is some outcomes are simply more common, more typical than others.
So instead of saying there's a 50% chance of this happening, we're saying 50% of observers across all branches would see this outcome. It's not chance within a single reality. It's more like the overall statistics of all those experiences.
Exactly. It's a total shift in how we think about probability, and it was and still is one of the most controversial parts of Everett's ideas.
It's kind of like those debates about free will versus determinism, but on a cosmic scale. From our perspective, it looks like things happen randomly. But maybe from some God's eye view of all those branches, everything's already set.
A good way to put it. And that's what's so thought-provoking about Everett. He forces us to question some really fundamental assumptions about reality, about how much we can even know about it.
So we've laid out Everett's core arguments, but I'm guessing not everyone was on board with this whole branching reality business.
Of course not. When you're proposing something this radical, there's going to be pushback. Some folks thought it was just too extravagant, too many unobserved worlds just to explain quantum mechanics.
Too much baggage, so to speak.
You could say that, but it's important to remember Everett himself didn't necessarily picture these like fully formed separate worlds constantly splitting off. He was more concerned with the mathematical logic of it all.
So it was others who came later with the whole many worlds interpretation label who really ran with the idea of parallel universes.
Right, and there's still debate about what Everett himself truly believed about those worlds. His original work is pretty subtle, open to interpretation.
So did he actually think there were like literal copies of us out there making different choices? Who knows?
The main point is he was committed to the idea of this universal wave function that doesn't collapse, and that our experience is like a specific perspective within that much vaster reality.
Okay, so that's Everett's main idea and some of the pushback it got. But I understand there are also like variations on his original formulation, right?
Absolutely. Lots of folks have taken Everett's core idea and, run with it in different directions, trying to solve some of the puzzles that his original theory raised.
Puzzles.
Yeah, like if everything really does happen, how come our experience is so darn consistent? Why don't we see more weird quantum stuff in our everyday lives?
Good point. So let's dig into those variations. They sound like they could shed even more light on this whole mind-bending topic.
Let's do it.
All right, so variations on Everett. What are we talking about here?
Well, one is called the Bear theory. It's like taking Everett's idea and stripping it down to the absolute minimum, just the wave function evolving according to the equations, no extra interpretations piled on top.
So no attempt to explain why we see one outcome, one reality. It's just the math plays out and that's that.
Pretty much, and that's where it runs into trouble, philosophically speaking. If everything's just the wave function and, there's no special role for measurement or observers.
Then how do you explain why our experience seems so classical, so definite?
Right. It's like you've got this map that perfectly describes all the possible routes, but doesn't tell you why your walk in the park feels so straightforward.
So the bear theory is a bit too bare. What else is there?
Well, then you've got things like the many minds theory. Now, this one gets really wild. Instead of the world splitting, it's our minds that are multiplying with every quantum measurement.
Hold on. So it's not me physically that's branching off. It's my consciousness. Like there's a version of me for every possible outcome?
Exactly. Each mind, so to speak, experiences one outcome, while countless other versions are experiencing all the other possibilities.
So in this version of me, I'm having coffee, but somewhere out there, there's another me happily sipping tea.
You got it. And this brings back probability in a new way. It's not what's the chance of this branch. It's more like what proportion of my minds will experience this.
Okay, that's a lot to process, but it still doesn't explain how those minds are distributed, right? Like why some outcomes are more popular than others, even among my infinite selves.
That's where things get tricky, and different versions of many minds gives different answers. Them tie it back to the squared amplitudes of the wave function, saying that determines the proportion of minds. Others get more speculative, like maybe there's some kind of mental momentum that guides minds towards certain branches.
Sounds like we're venturing into metaphysics territory here, trying to mesh quantum mechanics with like the nature of consciousness itself.
Yeah, it gets deep. But that's what's so cool about this stuff. It forces us to think about observation, experience, in a whole new light.
So we've got bare theory, we've got many minds. What else is on the menu?
Well, then you've got things like many histories and many threads interpretations. These are kind of different. Instead of thinking about splitting or branching, imagine a huge network of possible histories all laid out, like a cosmic choose-your-own-adventure book.
So it's not that new realities are being created, they're already all there, like parallel storylines, just waiting for us to tune into one.
Right, like the whole script of the universe is already written, every scene, every plot twist, and our consciousness is just experiencing one particular narrative.
That's a very different image. But it still leaves the question of how do we end up on one thread versus another? Is it random? Is it predetermined? What's the deal?
Yeah, that's the big question, and different interpretations give different answers. Some connected back to Everett's typicality, saying we're more likely to experience the typical threads. Others lean towards more deterministic ideas, saying, well, maybe our path is somehow set or influenced by factors we don't yet understand.
What strikes me is how all these ideas, even though they're different, they're all wrestling with the same basic problem. How do we square the weirdness of quantum mechanics with our everyday experience of one solid reality?
Exactly. And it's not just Everett. Even outside his framework, there are other interpretations that touch on similar themes. Like we talked about Bohmian mechanics earlier, which Everett himself wasn't a huge fan of, but
Right, Bohmian mechanics, trying to make quantum mechanics deterministic with these hidden variables that guide the particles along specific paths.
exactly. So in a way, it's similar to these multi-world ideas in that there's more to reality than what we directly observe. But it explains things like measurement and probability very differently.
It's amazing to see how many brilliant minds have spent decades grappling with this stuff. It really shows how interconnected physics and philosophy are.
Totally. And at the end of the day, Everett's work and all these variations that have sprung from it, they challenge us to think bigger, to question what we think we know about reality. It's humbling, in a way.
It is. Makes you realize how much we still don't know. So on that note, I think we've reached the end of our deep dive into Everett and the measurement problem.
It's been a wild ride through the quantum landscape.
It has, but hopefully we've given our listeners some food for thought, some new ways to think about the universe and our place in it.
And who knows, maybe some of them will be inspired to dive even deeper, explore these ideas further on their own.
That's what we hope for. After all, the quest for understanding never really ends, does it? And on that note, we'll wrap things up. Thanks for joining us on this deep dive, and until next time, keep those minds curious and keep exploring.